recording permission. Okay, let's share. So this conditional probability is something that uh, we already have seen that what is conditional probability, and the equation for conditional probability is probability of AB divided by probability of B. Okay, that intersection probability divided by probability of B. So whatever is in the last side, that will be in the lower side. And then we have seen the axioms of this probability. It is a similar kind of axioms. It will be positive if the condition is already fulfilled, then that probability will be equal to 1. And then this equation for mutually exclusive events, if I add them or if I union them, that will be equal to the total event, and the probability will be equal to the individual event addition. Let's solve this problem. Let's solve this problem. So when we have an example 1.16, look at this one. What actually is the same? Consider an experiment that consists of testing two integrated circuits that come from the same silicon wafer and observing in each case whether a circuit is acceptable or rejected, Okay. Consider the priori probability model is PRR equal to 0.01, PRA equal to 0.01, PAR equal to 0.01, and PAA equal to 0.97. Now tell me, what are these? What these probabilities are? We are talking about this probability. And
Sir, the probabilities of the two circuits being rejected is 0.01, right, and all of the preceding ones are intersections. In sorry, is it?
Actually, the thing is probability of, we are talking about two circuit, chip, or you can say two integrated circuits, IC, two IC check. Say the priori probability, don't look at one thing, a priori probability. This is before the experiment is done. From our previous experience, we have seen that if we test two circuits, then probability of both accept is 0.97, and probability of both reject or single reject is 0.01. This is the experimental results. That's actually we have found from previous cases. Okay, so these are some priori probability. That first one is reject and second one is reject is 0.01, then like this. But we are having some extra event, like event A, when the event is telling second chip rejected. What about first chip? I don't know. What about first chip? I don't know that. So probability of A, okay, the probability of A actually is something like this one. And this probability of A is second chip rejected. That means what? That means what is the probability of A? Second chip rejected is in which cases? This
RR.
Sir, RR and air.
AR. So when I'm talking about what is the probability of second chip rejected, then we have to add these two probabilities. So then probability of RR plus probability of AR. If I add those two, then we will find something like this one. Probability of 0, 2. That is the probability of A. Okay. Now what is the probability of B?
RR
Probability of
plus
B,
RA.
similar kind of things. RR plus probability of RA. Because this is the first chip rejected. Similar thing equal to similar result. So probability of A, probability of B finding is very easy. Now the last one is telling also find the conditional probability that second chip is rejected given that the first chip is rejected. What does it mean? Probability of what?
A divided by B.
Not divided by A condition B.
Oh, sorry, sir.
A condition B. Second triplication probability is A. So what is the probability of A given that first chip is rejected? That's what we want to find out. Probability of A condition B. So probability of A condition B is actually what? Probability of AB by probability of B. We know already that one. Do you know?
Yes, sir.
Yes, we know this one. So that one will be equal to what? What is probability of AB?
Sir, P
It
of
will be
RR.
probability of RR.
P of RR, right. Probability of AB means both first one and second one reject, and that is actually this probability of RR. So that will be 0.01. And probability of B is already we know 0.02, and that will be
0.5.
0.5. What is actually this one? This one is probability of second one reject, condition that first one is reject. Probability of second one reject and first one reject is what? 0.01. But why it is so high? Who can tell me?
Sir, is it because it is the second experiment and the first one is already rejected?
Remember one thing, when the first one is already rejected, the domain is changed. Previously, all the circuits were in the domain. But when the first one is rejected, then the domain is changed. Domain is what now?
Half.
It
Only
is
these
shrinked.
two. Only these two. Because first one is rejected means either it will be PRR or it will be PRA. Isn't it?
Yes, sir.
That's why, as there are two options and we are getting one single option, that's why it is 50% chance. So when you have already known that the first one is a reject, then actually the second one rejection probability is very high. It is 50%. You understand? This is
Yes,
the
sir.
conditional probability. Because now we are changing the domain. Previously, all the circuits were in the domain. But now, when the first one is accept, those circuits will not be in count. Only those will be in count where first one is a reject. That is why actually this P of A condition B is 0.5. Any question? There is no question. Okay. Let's go to the next slide. Okay. So already we have seen this one. We have already seen. Okay. Now let's solve another problem regarding the conditional probability. Roll two fair four-sided dice. What actually we are talking about? Two dice we are talking about. Okay, we're talking about two dice, and then look at this. This is one dice. Another dice is something like this, and I'm talking about they are actually not six-sided dice. They are four-sided dice. So actually, that will not be count. It will be something like this one. Isn't
Pyramid.
it?
Yes,
Pyramid.
sir.
Something like this one. Four-sided dice. So there are two four-sided dice. Okay. Now remember that means when I'm talking, there can be one dot, two dots, three dots, or four dots. Okay. Now when I'm talking about event A, look at that. Let x1 and x2 denote the number of dots that appear on die 1 and die 2. Okay. And what is A? A is an event when x1 is more than equal to 2. And A2 or B is an event when x2 is more than x1. how actually we can solve it? Let's do it in this way, that this is the x1 and this is the x2. What is the x1? In x1 side, it can be 1, 2, 3, 4 dots. 1, 2, 3, 4 dots. In the x2 side also, we can have 1, 2, 3, 4 dots. So we can have how many combinations?
16.
16 combinations. That means 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4. Is it clear?
Yes, sir.
Okay. So we have these 16 possible outcomes. This is very important. Okay. Because in one dice we are having 1, another one we are having 3, another one we are having 2, another one we are having 4. So this is one combination, this is one combination. In this way, there are 16 combinations. So there are 16 outcomes. So if I take the whole thing, that is the universal set, isn't it?
Sir.
Yes, sir.
Now, what is A? Event A. X1 is more than or equal to 2. So which outcomes will fall in this category?
Sir, the X1, 2, 3, 4 columns.
X1, 2, 3, 4, or this 2, 3,
Columns.
4, or this 2, 3, 4. So all these things will be into count, isn't it? Do you
Yes,
agree?
sir. Yes, sir.
Okay. Now,
Sir, one question.
yes,
Sir, the event A was x1 is greater than 2, sir. Does it, is it related to the second event, x2? It's not, right?
X2, no, X1 is independent. I mean, X1 doesn't mean that when I will talk about X1, I will talk only about X1. I'll not talk about.
Sir, do we need to consider all these conditions, because the 16 is depend upon x2 being rolled as well?
Yes, yes, of course. But when X1 is more than equal to 2, it means those outcomes where X1 is more than equal to 2. We are not talking about X2. X2 is whatever it is. Say, for example, X1 is 2. Say this one, X1 is 2. Here also X1 is 2. Here also X1 is 2. Here also X1 is 2. So whatever value of X2 there, they are, we don't need to think about it. We don't just need to think about it about the X1. A event is those events, those outcomes where the X1 value is more than or equal to 2. Whether its value is 2 or more than 2.
Right, sir. Thank you.
You are understanding?
Yes, sir.
I mean, these are the combination. That is true that I mean, when I'm talking about one particular point, there are two values. Either it is x1 value and also we have x2 value. But when I'm talking about x1 is more than 2, that means x2, we are not considering x2. Okay.
Yes, sir.
All right. So let's talk about the event B. What is event B? Event B is x2 is more than equal to more than x1. Every point or every outcome has corresponding x1 and x2, isn't it?
Yes, sir.
This value, how much is the x1
One.
and x2?
1.
One.
1. And you can easily understand that this line is a line where the value of x1 and x2 are equal, isn't it?
Yes, sir.
Above that line, what about this one? What is the value of x2
Four.
and x1?
Three.
3. So x4, x2 value is more. So in this B event, that is included.
Yes, sir.
Also,
Yes,
this
sir.
is included. This is included. So actually, we can think about that this whole area, we have to include this B case. So that is the B event. Do you agree? You can check.
Yes, sir.
You can check that these actually are. Maybe we can cut this. Otherwise, there are confusions. Ah, anyway. Okay, so let's just delete this one. Oh, this one. Risky as well. So we are having also uh, this one and this one. Okay, now this red area is about A and this green area is about B. Red area is about A and green area is about B. Is it clear to all?
Yes, sir.
Yes, sir.
Okay. Now let's find out what is the probability of A. They are telling us to find out what is probability of A. So probability of A will be what?
12 by
How do
16.
we find the probability? Probability is how many outcomes are there in that particular event divided by total number of outcomes, isn't it? So in
Yes, sir.
how many outcomes are there?
12.
12.
12. How many total number of outcomes?
16.
16. So when I'm talking about probability of A, then that is 12 by 16. That means 3 by 4. Now what about probability of B?
6 by 16.
6 by 16. Why? Because there are 6 elements. 1, 2, 3, 4, 5, and 6. There are only 6 outcomes. And total 16 outcomes. So the probability of B will be 3 by 8. So this is the probability of A and this is the probability of B. Now they are asking for probability of AB. Probability of AB is what? I mean, AB means A condition B actually. A condition B is, we know, probability of AB divided by probability of B. This is the equation, isn't it?
Yes, sir.
Probability of B, we know. How to find the probability of A, AB? AB is what? Intersection between A and B.
Yes, sir.
So
3 by
this is
16.
right, 3 by 16. How? Look at this one. This is the intersection. Okay. This one is the intersection. So 3 elements are there. So if I want to find out probability of A, B, that will be 3 elements divided by 16 elements. So what we'll do, 3 by 16 divided by probability of B is 3 by 8. So 3 by
Half.
16 into 8 by 3, and that will give us half. Clear?
Yes, sir.
Is it okay?
Yes, sir.
Sir, how the probability of B is 3 by 8?
AB, probability of AB means what? AB is the intersection between A and B.
Yes, sir.
What is the intersection? Look at that. What is probability of A? This is probability of A.
Yes, sir.
And what is probability of B? This one is probability of B. So which one is it? I mean common. Common is this one.
Yes, sir.
Common is this one. This is the common thing. Do you agree?
Yes, sir.
So common thing is how many? 3 elements are common. Out of how many elements? 16 elements. That's why it is 60 by 16. Is it clear?
Sir, I'm asking about the probability of B.
B.
Yes, sir.
Okay, probability of B is what? Probability of B is what? Look at this one. Probability of B is the event x2 greater than x1. This is the line. This is the line where the x1 and x2 are same. Above this one, will this be included? X1 equal to what? Tell me. X1 equal to what here?
2,
3.
3, 3.
3, 3.
3. What is x2?
X2 is 3.
Why x2 equals 3? This is in this line. Top line. Top line is 4.
4, 4, sir.
So x2 equal to 4. So x2 is more than x1, isn't it?
Yes, sir.
So this is included. What about this one? What about this one? x1 equal to what?
2,
2. x2 equal to
4,
4. So this is also included. What about this one? x1 equal to what?
1,
2. x1 equal to 2.
oh, 2,
x2 equal to
3,
3. So also this is included. What about this one? x1 equal to
1,
1, x2 equal to
2.
2. So this is also included because x2 is more than x1.
Yes.
So if you calculate this one and this one, also you will see that their value of x2 is more than x1 because this is the line of equal value. So above this one, anything is x2 more than x1. Below this, here, these cases will see x1 is more than x2. Okay, is it clear?
Yes.
So that's why actually these three values, I mean, if you want to find out this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, then you will see that these lines, these will be actually more than this value. Okay, so we have found out the A condition B is 0.5. How much we have found? 0.5, isn't it? So I think this is clear to you. Let's see the exam. I mean the result. Look at this. PA condition B. It will be more than this one. Is there any other questions regarding this solution? You can ask. No problem. Anyone? If you
Sir,
haven't understood, you can ask.
sir,
Yes.
does that mean that we are taking the x1 in column form, right?
X1 in column form
Column form, like in the diagram, I mean.
in the diagram.
Yeah, yes.
Look at this. X1. What is X1? When I'm talking about this point, this is what? It's a point where we have two coordinates. Say this is A, this is B, this is C, this is D. So A means what? A means x1 equal to 1 and x2 equal to 1.
One.
In the point B, x1 equal to 2, x2
Mm,
equal
two,
to
one, two.
1. Point C, x1 equal to 3, x2 equal to 1. Point D, x1 equal to 4, and then x2 equal to 1. Do you understand this one?
You mean for D?
For D, for A, B, C, D,
Okay.
do you understand this one?
The D part, please.
D part is, okay, D part I'm writing it again. D is x1 equal to 4 and then x2 equals to 1.
Can you show it on the diagram?
Look at this one. What is the x4 value?
Oh,
X1 value. X1 value is 4
yes.
and x2 value is 1.
Okay,
This is the
okay.
1.
Okay.
Okay.
Yes.
So every point has the value of x1, has the value of x2. Every point has the value of x1. How much value of x1? 3. How much value of x2? 3.
Okay.
This point, x1 value equal to 2, x2 value equal to 4. You know the coordinates, isn't it?
Yes.
X and y coordinate. So in the x and y coordinate, there can be any point. How to find the point coordinate value? Make a perpendicular on the x-axis, make a perpendicular in the y-axis. Whatever the value here, that is the x value of this one, and that is the y value of this one.
Yes, sir.
You know that?
Yes, sir.
Okay. So in this way, actually, we have found out the probability. Any other question? Any other questions? Okay, if not, then maybe we can go for the next slide. Okay, look at one thing. Law of total probability. how this law works for an event space B1, B2, B3, B4, Bm, as they are called it event space, there is no overlapping. So with B1, probability of B1 more than 0, for all I, we can say that probability of A will be equal to summation of probability of A condition Bi into probability of Bi. What is that? What is that? Look at this one. Say for example, oh, look at this. Say for example, we are having B1, we are having B2, we are having B3, and then we are having B4. Can you see it? Okay. From this point, maybe it can be A or it can be C. It can be A or it can be C. It can be A or it can be C. Also, it can be A or it can be C as well. Now, I want to find out probability of A. This is actually A means A condition B1. This is A condition B2. This is A condition B3. This is A condition B4. What does it mean by that? What is A condition B1? Probability of A where B1 has happened. As this A is coming from B2, we will say that probability of A condition B2 or probability of A when B2 has happened, like this. Now, if you want to find out this probability of A, this probability I can write probability of B1, we can write probability of B2, we can write probability of B3, we can write probability of B4. Okay, now look at one thing. If I want to find out probability of A, that means I have to take this branch probability plus this branch probability plus this branch probability and then this branch probability. This is, if I multiply and add, that will be the probability of A. Look at this. This is the law of total probability. What is that telling? We'll multiply this probability of A condition B1. Just a minute, just a minute. Just a minute. হ্যাঁ করলো দোস্ত হ্যাঁ ওয়ালাইকুম আসসালাম Hello. Hello.
Yes, sir.
Okay. Okay. The thing is, actually, I had a phone call, very important phone call. That's why I received it. All right. So the thing is, we were in a middle of this total probability, law of total probability. Okay. So the law of total probability is something like PA equals to I equals to 1 to M, probability of A condition BI, probability of BI. Okay. So we can understand if I want to find out the ultimate probability of A, total probability of A, then we have to multiply all the conditional probability with their prior probability. This is called the prior probability, and this is called the conditional probability. So we will multiply these branches, the branch number 1, branch number 2, branch number 3, and then branch number 4, and then we add them all. Okay, so it will be more clear when we will solve this example 1.19. Okay, all right.
Sir, I had one question.
Yes.
Actually, I'm a little confused. So
Yes.
we know that P of A condition B will be P of AB over P of B, right?
Right.
So, doesn't P of B cancel out each other in the right hand side, P of B,
Okay.
and doesn't P of AB remain only?
Okay, look at this one. What actually we are finding, if I talk about A condition B, all right, say what is that? Okay, P A condition B1 into P of B1. Okay, so what is that? We know that this is P of AB divided by P of B into P of B or B1, whatever it is. So we are cancelling each other. For actually, what is happening? P of A into B1. So actually, it is the multiplication of those two events, isn't it?
Yes, sir.
When it is coming B1 and then it is coming A, so actually if I multiply these two, actually the same thing. I mean, when I'm talking about A condition B1, multiplying with this is the same as multiplying with B1 and A, isn't it? Isn't it the same thing?
Yes, sir.
So actually, whether you use this probability of A into B1 or A condition B1 into probability of B1 is the same. So we are
Yes, sir.
actually multiplying this line or multiplying this branch, isn't it? Is there any other
Yes, sir.
question?
No, sir.
No questions. Okay. All right. The thing is, okay. So um, uh, all right. Let's solve this example. Let's solve this example. What is example 1.19? It is a company has 3 machines, B1, B2, and B3, for making 1 kilo ohm resistors. It has been observed that 80% of resistors produced by B1 are within 50 ohm of the nominal value. What does it mean by 50 ohm within nominal value?
It can be plus minus 50.
Plus minus 15, right? So I am producing 1 kilo ohm resistor. If it is plus 50 ohm, that is, if it is 1050 ohm or 950 ohm, I will take, okay, this is acceptable. But if it is more than that, that means they are not acceptable. They are rejected. Okay. So this is 80% for the machine B1. All right. Now machine B2 produces 90% of resistors within this 50 ohm nominal value. So there 90% resistors are acceptable. Then the percentage of the machine B3 is 60%. So how many percent of produced resistor are acceptable? It is already given. Now the percentage of for machine B, each hour machine B1 produces 3000 resistor, B2 produces 4000 resistors, and B3 produces 3000 resistors. All of the resistors are mixed together at random in one bin and packed for shipment. What is the probability that the company ships a resistor that is within 50 ohm nominal value. That means what is the probability of acceptable resistors, isn't it? Okay. So what actually is our idea? That means we are having B1, B2, B3. Okay. Probability of B1 is what?
0.8.
Probability of B1 is 0.8.
Oh, no, sir. It is
This
the
is the production
1 by
probability.
3.
yes, sir.
1 by 3. No, not 1 by 3.
Sir, it's 30%.
30%
0.3.
or equal to 0.3, right? 3,000 divided by 10,000. Because 3,000, 4,000, and 3,000. If I add, total 10,000 registers is produced by the machines, and out of the 10,000, 3,000 by B1, 4,000 by B2, 3,000 by B3. So definitely probability of B1 will be 0.3. Probability of B2 will be
0.4.
yes 0.4, and then probability of B3 will be
0.3.
0.3 again. Okay, now we have found B1, B2, B3. Now from that point, it can be accepted or rejected, isn't it? So from B1, if I say accepted, probability of accepted and probability of rejected. Again from here, probability of accepted, probability of rejected, isn't it?
Yes, sir.
And then again from here, it is probability of rejected and probability of accepted. Okay, now for this A, actually this A is same as A condition B1, isn't it?
Yes, sir.
This is same as A condition B1. So this is same as A condition B1, and that is equal to what?
0.8.
0.8, because 80% of the registers produced by B1 are within the 50 ohm of the nominal value. Okay, so 80% of the registers produced by B1 are within 50 ohm of the nominal value. So we can say that this is 0.8. Definitely this rejection is 0.2, and that PA equal to what? Or PA condition B2,
0.9.
this is 0.9, and that one is equal to 0.6. Is it clear to all?
Yes, sir.
Okay. Now I want to find probability of A. So probability of A from yes,
Can we leave for prayer?
yes, please, you can leave. You just write your roll number in the comment box.
Yes, sir.
Okay. So the thing is, probability of A will be equal to what? From the equation of this one, we must know that this is the probability of A condition B1 multiplied by probability of B1 plus probability of A condition B2 multiplied with the probability of B2 plus probability of A condition B3 multiplied by the probability of B3. Okay, so that is equal to what?
0.8 into 0.3.
0.8 into 0.3 plus this, isn't it?
Sir.
So whatever the result, that will be the probability of acceptance, ultimate acceptance. When I will make a bucket or make a box and keep all the registers here, then I will see that this many percentage of the registers will be acceptable. Do you understand?
Yes, sir.
So that is the result that we are asking for. Now let's check the result. The result is 0.78. So, and this 0.78 is the so 78% of the total production of the registers many registers are there, and then 78% registers will be acceptable, that produced by the company. The either it is from machine B1 or machine B2 or machine B3. Okay.
Sir,
Yes.
sir, is it like the more machines we set there and the more amount of register we produce, we can improve the accuracy?
Sorry again.
স্যার আমি বলতে চাচ্ছি যে আমরা যদি ফ্যাক্টরিতে মেশিনের সংখ্যা বাড়াই আর যদি আমরা প্রোডাকশনের সংখ্যাটা বাড়াই তার মানে কি স্যার আমার প্রবাবিলিটিটা ইমপ্রুভ হবে?
না,
Is it like that? Is it like that? Can you do that? Say for example, machine. I'm improving a machine whose accuracy probability is less. Then actually increasing the machine will decrease the probability. And if we are increasing some machine whose probability is higher, then the overall probability will improve. So number of machine, if I increase with the same kind of ratio, it will remain the same. More number of machine doesn't mean that more number of corrected products. Okay, is it understandable?
জি স্যার।
So it depends on what kind of machine you are actually increasing. Is it a good quality machine or bad quality machine? So for overall improvement, you have to improve the good quality machine, or you have to increase the good quality machine. Remember one thing, probability is something different. It is not dependent on the quantity. It is the ratio. Even if you increase more and more and more production, your ratio will be same. Okay. Any other question? If no question, then we can go on. Okay. Now let's go for the Bayes theorem. Okay, let's go for the Bayes theorem. What is the Bayes theorem? Bayes theorem says that in many situations, we have advanced information about P, A condition B. Okay. And we need to find out the opposite thing, that is P, B condition A. In a bucket, I am finding many, so all are acceptable registers. I have chosen one register. It is accepted. I want to know what is the probability that this register is coming from machine B1. This is the application of a Bayes theorem. From this, actually, we can find out the probability like this. Look at the example, then it will be more clear. Or before that, we can see this equation as well, because we know probability of A condition B equal to probability of AB by probability of B, and probability of PA equal to probability of AB divided by probability of A. If I divide, what will be that one? Probability of A condition B divided by probability of B condition A equal to probability of A divided by probability of B. Okay. The thing is, this one, if from this one, actually, we can find this one easily. All right. So let's see that this example 1.20, where actually every value is given. Probability of B3, it is given from the previous example. Probability of A, we have found out in the previous example. And in this example, it is given probability of A condition B3 is 0.6. It is also given. Now what we have to find out? Probability of B3 condition A. So from this equation, this is given, this is given, this is given. What is this one? We can easily find out, isn't it?
Yes sir.
We can easily find out. All right. So you just see the result, you can answer the question easily. Just put the values and you can find out that this is 0.23. That means 23% probability that acceptable register is coming from the machine B3, and 31% that they have also found out the other values as well. That is B1 equal to 0.31, B2A equal to 0.46. So actually look at this one. This, if I find a acceptable register and I'm finding that probability of B3 condition A is 0.23, B2 condition A is 0.46, and then B1 condition A is 0.31. So these are the probabilities that we can find out by using Bayes theorem. Let's, do you have any question? If not, then let's stop it here and we will solve the next topic in the next class. Okay? Is there any question?
No, sir.
No. So if not, then we stop the class here and we'll talk about independence in the next class. All right? Let's take the attendance.